Hello my dear students. In this video I am going to talk about evaluation of double integrals. We are going to discuss three types of double integrals. The first one is of the type integration of the function f of variables x and y with respect to y from c to d, and then with respect to x from a to b. Or in other words, we can write it as integration of the function x plus y with respect to y from y is equals to c to y is equals to d, because we are integrating with respect to y first, so we need the limits of variable y. Then we are integrating the answer of this first integral with respect to x, taking the integral from x is equals to a to x is equals to b. This type of double integral has constant limit of integration. For example, we want to solve the integration of the function x plus y with respect to x from 0 to 3, and then with respect to y from 1 to 2, right? It means that these 0 and 3 are the limits of integration with respect to x, and 1 and 2 are the limits of integration with respect to y. So we can simplify this integral as the integration of the function x plus y with respect to x from x is equals to 0 to x is equals to 3, and then with respect to y from y is equals to 1 to y is equals to 2. Now we will integrate with respect to x first, so that would be equals to x square over 2 plus x times y, right? Taking the limits of integration, that is x is equals to 0 to x is equals to 3. Then the answer of this should be integrated with respect to y, where the limits of integration are y is equals to 1 to y is equals to 2, right? Now applying the limits of integration, that should be 9 over 2, because that is 3, so 3 square divided by 2 plus 3 times y, so that should be 3y, minus 0 square divided by 2, that should be 0, minus 0 times y, that should be 0, so no need to write 0. Now this answer should be integrated with respect to y from y is equals to 1 to y is equals to 2. Integration of 9 over 2 plus 3y is equals to 9 over 2 times y, because we are integrating with respect to y, plus this should be 3 over 2 y square. Taking the limits of integration with respect to y, which is y is equals to 1 to y is equals to 2. Applying these limits of integration, that would be equals to 9 over 2 times y, which is 2, plus 3 over 2 times y square, means 2 square, minus 9 over 2 times 1 minus 3 over 2 times 1 square. Now simplifying this, we'll get 9, that would be 3 times 2, that would be 6. This should be minus 9 over 2, this should be minus 3 over 2. So simplifying this, this would be equals to 15, and this should be equals to minus 9 minus, that would be 9 plus 3 becomes 12, so that becomes 6, and the result of this double integration is 9. Means that integration of the function x plus y from 0 to 3 with respect to x, and then with respect to y from 1 to 2 is equals to 9. So this is how we evaluate the double integration with the constant limits of integration. One more thing which you can notice here is that you can switch the order of integration here. For example, you can integrate the function x plus y with respect to y first, taking the limits of integration of y, which are basically 1 to 2, then with respect to x, taking the limits of integration 0 to 3. The answer should be same. Okay, let's evaluate it. So integration of x plus y with respect to y would be x y plus y square over 2, taking the limits of integration of y, which is y is equals to 1 to y is equals to 2, remaining dx, integration with respect to x from 0 to 3. Okay, applying the limits of integration, that should be the values of y, so that would be 2x, because that is x times y, y is equals to 2, so that would be 2x plus 2 square over 2, so that would be 2 square over 2 minus x times 1, so that is x minus that should be 1 square over 2, so that is 1 square over 2. These are the limits of x, so that should be 0 to 3 with respect to x. Okay, now let's simplify this. So that would be equals to 2x minus x, that would be x, plus 2 square over 2, that would be equals to 2, and this is minus 1 upon 2, so that would be 2 to the 4 minus 1, that would be 3 over 2. So instead of writing 2 minus 1 upon 2, we are writing 3 over 2, so that would be 3 over 2 integration with respect to x from 0 to 3. Now integration of x plus 3 upon 2 with respect to x would be x square over 2 plus 3 over 2 times x, taking the limits of integration with respect to x, which is x is equals to 0 to x is equals to 3. Now applying these limits of integration, we will have 3 square divided by 2 plus 3 upon 2 times 3, then minus 0 square divided by 2 plus that should be minus 3 over 2 times 0, right? So when we simplify this, that would be 9 over 2, this should be 9 over 2, this would be 0. So when we add them 9 upon 2 plus 9 upon 2, so that should be equals to 9. And just now we saw that the integration of x plus y with respect to x first and then with respect to y, the result was 9, and the result becomes same when we change the order of integration. And this is the case only when we have the limits of integration as the constant numbers. So the double integral with all the constant limits of integration gives you the same answer if you change the order of integration. In the next video, I will be talking about another type of double integral. I hope you like this video. If you have any questions, you can write them in the comment section. I will be trying my best to solve your queries. Thank you very much.